Good morning, good afternoon, good evening. My name is Jen Guile. Welcome to Microservices March. For everyone who has joined us through the registration, you already know basically what this is about. For people who found us through social media and YouTube, the month of March is the time when the NGINX product group from F5 focuses our education on a microservices topic, and this year that topic is Kubernetes networking. So the program will be running from today all the way through the end of March. Without further ado though, let's go ahead and jump into what we're here to talk about today. Our first unit is architecting clusters for high traffic websites, and with us as our featured speaker is Salman Iqbal from Learnk8s. Good morning from Seattle, Salman.
Hey, good afternoon from Cardiff, Wales. Woohoo!
Woohoo! It's probably about as rainy there as it is here.
No, it's actually surprisingly sunny. I think it's because of the webinar.
False advertising, right?
Indeed, indeed.
All right, I'm going to go ahead and hand it off to you. We do have the comments open across all our platforms. So we do have people in the background who will be answering questions as we go. And then we'll take time toward the end for about 15 minutes of live Q&A.
Perfect. Thank you very much, Jen. Hey, welcome everybody. My name is Salman Iqbal, and thank you all for having me. Before I start anything, let me set the scene for you before we talk about anything. Imagine you have a website that's running on Kubernetes, and you're getting some traffic to it. People are happy, and your website is getting served correctly, and everybody's receiving whatever the information they're supposed to receive. But your website becomes very popular and you receive a ton of traffic. That's an actual metric, by the way, a ton of traffic. But your website can't handle it anymore, right? So what happens then? Well, that's not really an ideal situation. What we really want is, we live in 2022. What we really want is the website to autoscale itself when it's under load. And that is what we're going to discuss about today. And also, we'll discuss what Kubernetes is and how it helps. So, my name is Salman Iqbal. I'm a Kubernetes instructor with Learnk8s. I'm also an MLOps engineer with Appia. You can find me on Twitter at Salman Iqbal. And I do also have a YouTube channel. Do find me on there, Salman Iqbal. I make Kubernetes videos, like short, informative videos. If you like to learn a little bit more about Kubernetes, do jump there. Before I do anything, I'd like to thank my friend Daniele Plencic from Learnk8s. He's put in a lot of hard work in this demo. He's put this demo together. And yeah, it wouldn't have been possible without him. And it would not have been possible without the beautiful folks at NGINX. Jen, Brian, and Marco, they've been awesome to put this all together. So thank you, Jen, Brian, and Marco. And they're here to answer the questions. So if you have any questions about Kubernetes, about NGINX, about anything that we're discussing today, please put them in chat. And my friend Chris from Learnk8s is also there to answer your questions. Do comment in YouTube. Let us know where you're joining from. It'll be cool to see that. This is, as Jen said, the first in many. So we've got 3 more sessions coming up. Andrea and Chris from Learnk8s are going to talk a little bit more about Kubernetes networking. So head over to nginx.com/mm and sign up. So here's the agenda. If you're new to Kubernetes, don't worry. I'll explain a little bit about what Kubernetes is, why would you want to use it, and then we'll break down some components of Kubernetes. We'll talk about deployment, services, ingress, what they are, and then the bit that we're all looking at is autoscaling ingresses, or any pod for that matter, any other application. So that's the agenda. But before we jump into it, it's good to set the scene. How do we get here? We all started with a monolith, right? We had a big application which was running our stuff, our application in there. And then that monolith was a bit too clunky to release. And if you need to make changes, it would take time. So people start to realize, you know what? We'll start to break this application up into different components. So people start to break application into different components, and we started to realize that, okay, these different components can be the authorization service, or the API, or the front end, or the worker. So now we ended up in this microservices architecture that we have. You don't just end up with one from one application. You might not just end up with 4 components. You might end up with multiples of components, 50, 60. And if you have many applications, you might end up with many more. And managing them does bring a bit of challenge. For example, if you had a monolith before, you just deployed in a virtual machine and everything would be good. because you just spin up a virtual machine, deploy it on there, no problem whatsoever. But then as soon as you start to break the application into smaller components, we need to find a way to isolate these components, because if one of the components in the virtual machine has a memory leak, it might hog on to all the memory that the rest of the components might need. So that's a bit of a problem. And then what we decided was, you know what we can do? Instead of having one massive virtual machine, we can stick them all on smaller virtual machines. That makes sense, and just wrap it in. But you might end up with many virtual machines because you have many components to deal with. So that's okay, but you got to manage these machines. And also, all these machines are, reasonable in size. You have to have some resource allocated to running the operating system and the rest of the resource to running the application, which doesn't sound too bad until you realize that if you have every machine, you need about 6 to 10% overhead of just running the operating system. And if you have hundreds of machines, that could be a bit of a problem. And then we also realized that every time we deployed these applications, they had a different memory or CPU profile. And sometimes when these applications got deployed into each virtual machine, they would leave a lot of underutilized resources. So that's a bit of a challenge there with virtual machines. And also, I'm sure you've had this happen to you. Somebody's written an application and they ask you to run it. You follow the instructions and you run it, doesn't quite work. And you ask them again, it's not working, what happened? And they tell you they forgot to tell you need to install a package. And that can happen because the virtual machine, you need to install all the dependencies, everything you need to have in order to run your application. So, and this is where containers come in. They take away some of these challenges and improve them. What is a container? I'm going to give a really brief description. I'm sure most of you know what containers are, but if you don't, I'll just give a quick description of what container is. So what you do is you get a runtime. In our case, it's a Java virtual machine. It could be anything. You might be running .NET, Golang, whatever application it is. You pick a runtime. And then you grab all the dependencies that you need and your files for your applications. All the files, your application files, your configuration files. You stick them. And any of the dependencies that you might have. This is Java cryptographic extension or any packages that you might want to install. And then you basically containerize this. So you make an image out of this. You package it all together. That becomes a container. When you have a container, I'm sure you've come across Docker or some other container runtime. You can take this container, you can run it, you can give it to somebody. All they have to do is Docker run and start the container. You don't have to worry about provisioning the environment beforehand. And you can start perhaps packaging all these containers together and not run them in separate virtual machines. So that's where the containers are. So the containers help us with some problems. That's cool. But another problem is that when you run a container on a virtual machine, if it's just one machine, that's okay. If it stops, you can start it back up on the same virtual machine. But what if you have multiple servers? You don't have just one server because you don't have enough resources on that server to run all the containers. So you might say, you know what, I'll pick 3 machines and run them on there. And one of them is a specific machine because that has a GPU attached to it. And there's a workload that's running with the GPU. Then how do you make sure that if it crashes, it comes back up onto the same machine and not end up on a machine that doesn't have a GPU? And how do you make sure that how do you make sure you deploy all of these things with maximum efficiency and not deploy everything on one machine? You don't want to be logging into each machine and running it. Another challenge is when you're deploying the containers on one machine, all containers can talk to each other using the Docker network. Imagine if you have a Python application that talks to MySQL Server. That's no problem. You can use the name of the container and it will resolve it to an IP of that container and everything will work fine. But when you're into multiple machines, that Docker network doesn't work anymore. So we need to find ways to connect multiple networks together. And this is where Kubernetes comes in, or container orchestration of any sort. But today we're going to talk about Kubernetes. Imagine having a Kubernetes cluster with 2 compute resources, right? So a cluster is usually made up of a control plane, which is the thing on the right, and other worker nodes. And the worker nodes, this is where you deploy your containers. In a Kubernetes cluster, you can have a cluster of any size. You can have any number of machines. You can have multiple control planes. but we won't go into too much detail. If you want to learn a little bit more about that, you can head over to Learnk8s.io. We've got plenty of blogs on there and on the NGINX website explaining what it is. But the idea behind Kubernetes is that you actually don't log into each machine to submit and run the containers. You just submit it to the Kubernetes API, and the Kubernetes API decides, along with other components in the cluster, which is the best node to deploy the workload on. So if this comes in, the node on the left is empty, it deploys it. We're not doing this. We're not saying deploy it onto this machine or that machine. Kubernetes takes care of that. A replica of the same application comes in because we've got this high traffic for this application. So a replica comes in and that needs to be deployed. Kubernetes says, you know what? There's one instance of it running on the left node. So we need to have some redundancy. What if that node goes down? So it deploys it on the other node. And then this keeps happening. You can keep submitting your containers with different requirements. It looks at your requirements, CPU and memory requirements, and it just keeps deploying it. And basically it starts playing Tetris with your containers and starts deploying where it thinks it sees it best fit. By the way, if you have any questions, feel free to keep putting them in the chat, and we'll get to answering them soon. Now, so that's Kubernetes in a nutshell, very high level. I haven't gone into too much detail, but how do you actually deploy applications onto Kubernetes? Let's have a look. We'll take a simple example, super simple example. And what we'll do is now first we'll break down perhaps the terminologies you've come across in Kubernetes. We'll briefly describe what they are, and then we'll jump into what we need to do. So this is a basic static web page, a red web page, nothing special about it. Just you log in and it shows you the red page. A user can visit this website by going directly to the app. And you can do that if it's running. But we're saying we need to have, we might have a high traffic. So we need to have multiple instances of this website running. So what we do is we can have a load balancer, right? So a load balancer is designed to evenly distribute the traffic between both instances, because we want to make sure that not just the one instance keeps getting all the traffic. And if you wish to expose more apps, right? So you can deploy more apps, but then somehow you need to figure out from the request that's being sent from the user that you need to either send it to the red app or the beige app on the right. And if that's the case, what we do is we add another load balancer on top to distribute the traffic to the internal load balancers. So we got internal load balancers and we got actual load balancers on top. So the internal load balancers are actually in Kubernetes called the service. I know it's quite confusing because everything in computing is called a service, but that's also a service, and we'll break down what services are. And then the bit that brings in the external traffic and distributes it down to where it needs to go is called an ingress. And today we'll talk about ingress too. And another bit is that the application or the container that's running, it's not called an application or container. Instead, we call it pods. And in a pod, you can have multiple containers running if need be. So services, ingresses, pods are basic components of Kubernetes. And we'll in the labs, when you get your hands on it, Jen is going to share the link afterwards. You'll get to deploy them, and I'll show you some deployments as well. Now, there's another component object that's fundamental to deploying pods, and that's called deployment. In this picture, you see one ingress, one service, and 5 pods. And there's another component that's not visible, and that's called a deployment. A deployment is just a recipe to create more pods. And you can define what the pod should look like and how many instances of the pod should be running at all times. And Kubernetes will make sure that all those instances are up and running at all times. If for whatever reason, one of the pod is deleted, Kubernetes realizes that and says, well, I should be having 5 replicas of this pod running at all time. So it spins back that replica up. And how do we do all these deployments? How do we create all these resources? How do we create the service? How do we create the ingress? How do we create a deployment? How do we create a pod? I'll show you a quick example of how you actually create a pod. You can create them using kubectl commands, or we can use a YAML file. You can also define them using JSON files, but mostly people do tend to use YAML files. In the YAML files, you have like key value pairs and you have lists. But as you can see at the bottom of the page, there's the image called NGINX that defines what image you want to run in that pod. And also there's some other information about what the name is and what the kind of that resource is. This a pod, a kind is a pod. And we've got some labels that we can use to identify what the application is that's running inside. The same goes for deployment, same goes for ingress. They all have different values that you need to put in. So once you have this file, you can take this file and you can submit this to your Kubernetes cluster. And that cluster could be running anywhere. It could be running on your machine. It could be running in the cloud, wherever it might be running. And kubectl is a command line tool that you can use. What you do is, let's say, you say, I want to deploy 2 replicas of an application. You don't want to do a deployment. You take a YAML file. I mean, I showed you a pod example, but you can take a deployment file. You take that YAML file and you submit that to a Kubernetes cluster using kubectl, apply -f, name of the file, and send it over. And Kubernetes cluster receives that request. Well, actually, there's a component called the API server, which receives the request. There's other components inside, but we're not going to go into too much detail. There's other components inside, controller manager and scheduler, and an etcd database. But what they're trying to do is try to deploy a pod for you. Once the request is sent in, Kubernetes looks around, which node is free, which node is the best node to be able to run that, and spins up the pod. And once the pod is up and running, here's what Kubernetes does. It assigns an IP address to every pod. So every pod gets an IP address. And the port here is what port that website or whatever is inside the container running. If it has an IP address, you can imagine you can reach this pod from one pod to another pod. And then what we also deploy, if you wanted to be able to send and receive traffic, we also deploy what's known as a service. A service is, as we said earlier on, internal load balancer. But you might be asking, why are we deploying a service? Why can't I just have a pod and talk to another pod? Well, instead of pod making requests from one pod to another pod, what we could do is make a request to a service, which is an abstraction on top of the pod. And that's useful because imagine you have multiple pods. So the red pod wants to talk to a beige pod. You know, this is gathering some data that's running in a MySQL database inside a pod. Now, if that's the case, how do you pick which pod to run? But if you make a request to the service, if the pod makes a request to the service actually decides which pod to pick. Now, there's 4 different types of services. We'll look into it in a little bit, but it will pick one and try and make sure that the load is balanced. So the red pod doesn't have to remember what the IP addresses of those pods are. It just knows what the service is. Service has an IP address and sends the request, and the service picks up this pod on the left and sends the request there. Once that happens, you can have multiple. You can not just have 2 pods. You can have multiple pods. You can have, instead of 2, you might end up with 10 pods. When that's the case, that means the service itself will decide which pod to send the traffic to and reduce it. If the pod gets deleted, it will create it up. So that's what the services are. Now, now that's what the service at high level is. But I said there's 4 different types of services. Now, all these services have a slightly different behavior. The basic service is called the headless service, and it's the building block. We're not going to go into too much detail on what these different services do, but basically the point of these services is to pick a pod to be able to send the traffic by doing either round robin or using probabilistic selection. But different services pick a pod in different ways. The headless service is the basic one, and then we have cluster IP. So when you have cluster IP service, that's the default service type. And it extends headless and provides a service that's closer to a load balancer. Now, those 2 services are internal services. So headless and cluster IP is for internal traffic. And NodePort is basically used to expose the service to outside of the cluster. So right now with the current services, you can't get basically the external traffic into the cluster. But you can use this NodePort service outside the cluster. And how do you create these services? Again, with YAML files, right? You have YAML files, and I'll show you an example in a little bit when we do a demo. And where you can define a different type of service, and there I'll show you an example. So NodePort is for like external. And it can be used to expose the pod to the external traffic. And then LoadBalancer extends NodePort. And this service is particularly useful if you are in a Kubernetes managed service in the cloud, such as EKS or Google Kubernetes Service or Azure Kubernetes Service. Because what cloud provider does is when you create the service, it will actually attach a load balancer to it. So you can hit the load balancer and access your pod. But beware, load balancers are not cheap. And if you end up with 20 services, you might end up with 20 load balancers that are running. So that's one thing that you have to be careful of. But that's not the only thing. There's a couple of things with services that you have to be careful of. A load balancer is attached automatically, so we don't really need to like wire components or anything like that. We don't have to do any of this. The load balancer, the cloud provider will provision and attach it to our service, and the traffic will flow. But it's for cloud providers. It doesn't really work if you're on premises, or like somebody has to configure that. Or if you're on premises, you can use some other providers like MetalLB. I think the main thing is the load balancer and NodePort are useful if you wish to expose services that use layer 4, TCP and UDP. And if you have like website traffic, layer 7, that is where it falls a bit short. Let me tell you what I mean. So we discussed so far that it's convenient to have a service that acts as a load balancer that can pick a container. But what we do instead, if we want to expose externally, we add this component called the Ingress, which allows users to send traffic and route it down based on the request that they're sending. So in the request, you could go to example.com/checkout, and it'll take you to a different service. Example.com/bin, it'll take you to a different service. So this routing is quite common. If you have a website, you might have several components. Let's say you have checkout, you have list, you have account. And somebody might send a request to your load balancer. And what you want to do is if somebody puts in a request to /account, we want to send it to the red service. Or if they send a request to / in their HTTP request to /checkout, we want to send it to the yellow pod, which goes via the yellow service. Or we can use the same logic to host several websites under the same cluster and decide to route the traffic based on the domain name. Somebody might say, I need to go to m.domain.io, and we want to send them to the green app. There's more use cases, though, for this for Ingress. What we want to do is basically forward the request to the correct application based on the path and the domain and the headers that we were showing. And we want to make sure we can ingest a large number of requests while keeping this latency low. We also want to do SSL termination, right? We want to make sure our traffic is encrypted, and we want to apply policies such as rate limiting and authentication. Well, I'm not going to talk anything about the rate limiting and authentication, but you're actually in luck, because next Monday, my friend Andrea from Learnk8s is going to talk about rate limiting. How do you rate limit? How do you make sure that your application doesn't get overwhelmed? So yeah, do sign up, nginx.com/mm. Sign up. That's a talk. It's a really awesome talk. Has a great demo as well. So he's going to be there next week. So, well, going back to where we were, 5 more minutes, couple more minutes, and we're going to do the demo, and you'll see. But what are we trying to achieve? So what is this Ingress bit? I've told you at super high level what it is, but let's try and break down what is it actually. So far, you've seen Ingress as the black bar here at the top. But it turns out that Ingress is just a regular deployment. A deployment, i.e. the recipe on how you want to create pods. So it's a regular deployment plus a service, usually a NodePort or load balancer service. Doesn't matter, it's just one of them. There's another bit to it, right? So there's a deployment. Ingress usually comes in 2 parts. So what's known as the Ingress controller, which is the part of a deployment, so web server, NGINX in this case, my favorite Ingress controller, definitely not biased here. And the other component is the Ingress manifest. The Ingress manifest is the rules on how the traffic should be routed. So basically, when people are talking about Ingress, we've got 2 components. The Ingress controllers, the web server that basically takes those rules that we write and implements them, how to forward the traffic based on these HTTP rules. what does a manifest look like? So this is what an Ingress manifest looks like. If I open an Ingress file, you can see in here, this is like an older version of an Ingress file, but it's an Ingress file. But I want you to look at the spec rules HTTP paths. All that says is if somebody hits this Ingress, send them to the service name called my service and on the service port 80. We'll show you in a second what it looks like. And we'll also show you, I'll show you how to install an Ingress controller on your cluster. And we're going to install an NGINX Ingress controller. Only takes 2 commands to do that. So what happens is the request for an Ingress, we submit it to the API server. API server receives the request, and whenever an API server receives a request, it takes that information and writes it in a database called etcd. That's where all the information is stored. All the state of your cluster is stored. And then what we have is 2 more components, controller manager and scheduler. Controller manager just watches over things when changing in etcd and acts on it. And scheduler is the one that basically decides where the pod is going to run on which cluster. So Ingress controller is actually a programmable router. When it starts, it connects to etcd in the control plane and retrieves all the Ingress manifests, all the rules that we wrote that said, if somebody hit this address, send them to this service. So in our case, it says, oh, if somebody requests to Ingress 1, send them to the front end service. And then we can write another Ingress with a different rule or another rule. And that says if somebody hits Ingress 2, send them to this backend service. So basically, the Ingress controller is just watching for all these changes. Every time somebody adds a new rule, a new pod gets added, all this is doing is just basically is grabbing those rules and putting them in the pod. So when the traffic comes from outside of the cluster via an Ingress, it goes to the Ingress pod, in this case, NGINX, and the NGINX decides, okay, where do I need to route this traffic to which service? So this basically keeps reading it, keeps reconfiguring it, and all is good. Oh, well, I'm not sure why this is here, but if you want to learn a little bit more about Ingress and services, I've actually got some videos on YouTube. Check it out, Salman, Iqbal. Also check out the NGINX YouTube channel that you're on. Like and subscribe. You know what to say. Do that. So, almost time for demo. Ingress controller. I know you hear me say NGINX, 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 but there's bound to be more, right? Yes, there are many more. So Ingress, NGINX is one of them. We're going to look at that. There's Ambassador, Contour. The list keeps going. That's not everything on there. How do you pick an Ingress? Which one do you go for? Well, first of all, you can read the documentation and see if you can do a comparison. We actually got some information about that on our website, learnk8s.io/research. We have a Google Sheet which compares all the features of it, and you can look at those that research and pick one. NGINX. Well, pick whichever one is best for you. So here is what we are here for today. This is the demo. And what am I going to show you is, imagine this is our setup. We've seen the setup so far. We've got some incoming traffic. We have an NGINX controller inside. It's receiving traffic, and based on the rules we wrote, it decides where it needs to route the traffic to, right? And traffic goes to the red pod or the beige pod or whichever pod. Something happens, and we start to receive tons of traffic, tons of incoming traffic, right? So this is our metric for measuring the traffic coming in. And then we know that request has to go to the Ingress NGINX pod because it needs to figure out what are the rules. But the pod will start getting overwhelmed if there's too many requests. And you might start to say to me, yo, Salman, but it's 2022 and there's a land of Kubernetes. I've heard it can autoscale. Well, not quite. We have to do some work for it. The great thing will be is if we do a bit of a setup, and if there's a ton of traffic, Ingress NGINX pods scale up automatically based on some parameters. That's what we really want. We can grab some parameters, see if one of this pod is getting overwhelmed, and based on that request, we can install those. We can scale up. So what you can do is, when you deploy Ingress NGINX, of course, I'll show you in a second what you can do or how we deploy it using Helm. But what you can do is you can manually open a deployment file. The deployment file defines how many replicas of specific pod are you running. And we said Ingress is also deployment, right? So when you realize, when your customers keep calling you and say, oh, your website is down, I can't buy what I need to buy. So you can open you can open a deployment file, and you can manually increase the replicas from 1 to 3. You can do that manually, but no, we don't want to do that. That's not cool. I don't want to wake up in the middle of night at 2 a.m. to increase the number of replicas. There's bound to be a better way. Well, there is. So this is what we can do. Imagine our deployment says, that's in the cluster already, that we want to run 3 replicas of NGINX at any time. There's a component called the horizontal pod autoscaler in Kubernetes. What it can do, based on some metrics they can grab from the pods, you can scale up or scale down that pod. So what we really want to do is somehow query those metrics from those pods. Get that information. Could be the number of connections that are running in the pod. Could be the response time. Could be the number of, how long it takes, how many errors you're getting. Could be any metric. You can pick any metric you like. And then what you want to do is the horizontal pod autoscaler grabs all those metrics and does some calculation and then adjusts the deployment based on that metric. Maybe you've decided that your metric for scaling up or scaling down is that if there's too many connections in the pod, scale up by another replica. And we'll see in a second how we do that. And once it adjusts, it will scale up if needed to. And if the requests go down, we'll scale back down. But how do we scale on HTTP requests that are coming in? Because that's our plan, what we need to do. Well, the first thing we need to do is grab some metrics from those pods. So if you're writing your own pod, you have to make sure you expose those metrics somehow at an endpoint, /metrics, and expose some key value pairs from your application. And then what you want to do is grab those metrics and store them. You have to grab them from somewhere, grab them and store them. So you can then use an autoscaler to be able to automatically scale those NGINX pods that you're running. But we're in luck, people. We are in luck because NGINX pod by default exposes these metrics. So I actually don't have to do any work. And what we'll do now is we'll look at this metrics, which is active connections in the NGINX pod. If I have too many connections, let's say if a pod has to handle more than 100 connections, scale up, give me another pod. If it's more than 2, give me another pod. So how do we collect the metrics, right? Now we need to be able to collect the metrics. So we'll use another component. We don't want to do all this manual stuff. What we can do is install Prometheus. It's an open source monitoring system, and it's pretty awesome. There's 2 ways to install Prometheus, with an operator and without an operator. And NGINX Ingress uses annotations. So we'll go with the easiest choice. You will have all the steps to do this, by the way, in the lab afterwards. So that's not a problem. So we're collecting metrics. The first one is which metric we want to pick. We'll pick the metric that we wanted. The second one was collecting and storing metric. And the third bit is the autoscaler. Now, the autoscaler, somebody needs to take that metric from Prometheus and feed it into horizontal pod autoscaler so it can scale up or scale back down. And this is where we're going to use this open source tool, Kubernetes event-driven autoscaling CKAD, which works alongside the horizontal pod autoscaler, grabs those metrics from Prometheus and scales them up. Now, this is the time for a demo, and I'm going to be doing a live demo. We'll install everything together. It shouldn't take too long. And what we'll see is we will simulate some traffic onto our Ingress NGINX pod. And what we actually want to see is Ingress NGINX scaling up from 1 to as many as it likes and handle all the traffic, and everybody's happy. So I'm going to switch my screens. And if there's any questions, I don't know, Jen, if you want to pop in and ask questions, and please feel free to keep doing that. So right. Now, let's do this.
Salman, we do have one request to clarify what actually is Ingress and how is that different than an Ingress controller? Okay, cool. That's a very good question. So an Ingress controller is a pod that runs inside a cluster that takes I'll actually show you in a second. The Ingress controller is the pod that runs inside the cluster. By default, your cluster doesn't come with an Ingress controller. That's the bit of logic that runs in a cluster
that can handle your layer 7 traffic and route it based on the HTTP request that gets sent. So that's the Ingress controller. And the Ingress resource that we create in Kubernetes is the rules that we deploy. I'm going to show you in a second what Ingress is. It's saying when the request goes to this address, send it over to that pod. And I'll show you in a second. Does that answer the question, Jen? Is that?
I think so. Chris or
okay. Yeah, so the Ingress control. Yeah, so the Ingress kind Ingress, which is a resource, can exist in the cluster without the controller. So controller is the bit that implements that logic. It can exist in the cluster, but it doesn't do anything. It'll just sit there. And you can have a controller that reads that logic and implements it. Or you can also have multiple controllers if you wanted to. Right. Should we jump into the demo?
That answers that. Let's keep rolling.
Yep. Perfect. So what I have, and this is what you will have as well in the demo, I've got this terminal here, and I have a local Minikube cluster running. You can use any cluster you like, and you'll have all the steps for this once we're done. Jen is going to share that. So I'm using this command line tool, kubectl get nodes. And all you'll see in a second is I've just got one node that's running. And before I do anything else, I'm just going to bring up a dashboard for us. 1 second. Let's just bring it up just for us. So this cluster is empty, right? So there's just the basic components that are running inside. I haven't deployed any application. Nothing's happened in there. So I'm going to bring up this dashboard, which will let me bring it up, which will show us how many pods are running in our cluster at any time. And that's useful because what we can do is when it's scaling up, we can see if the pods are scaling. Now, these I'm going to make that small and put it onto the side here. And these are the pods. These are the Kubernetes pods. I know it's quite small, but the name of these pods is not important. But these are the basic Kubernetes pods that are running inside Minikube. And when we deploy an Ingress NGINX or a different pod, it comes up here. And I'll go back. We'll have a look in a second. Now, so if let's just go in, F5. Right. Let's have a look. What we're going to do is deploy an application. If you never deployed an application in Kubernetes, this is where we're going to do it. So I showed you a YAML file before, a pod YAML file. This is a deployment YAML file. We define what a kind deployment is. So this is a resource type. And what image we want to run inside, which is this image that we're using for Stefan Prodan. And it just shows a static page that's running that we can ping. The deployment has information about replicas. In here, we haven't really got any replicas. We just basically want one replica. And container port is the port that the container runs on. And the rest of the information is about like the labels and what kind of things it uses. Another thing in here is a service. And we're talking about the service acting as an internal load balancer. We could have multiple instances of that running. So we're dealing with a deployment and a service now, and then we'll hop into Ingress. And this thing says it's a type load balancer, as we were saying earlier. Selector is pod info, so basically it's going to send the request to the deployment that's created. And the target port, it matches the container port. So what we've done, I'm going to show you a quick diagram in here, is this. Once we deploy it, we'll have, Ingress is not here yet, we'll deploy this pod, and we'll deploy a service, and we just make sure these container port matches so the request can be sent directly to it. So let's just jump back, and I have this deployment file in here, which is this one deployment, and I will create this now. So if I move that up a little bit, give me a second. So these are the files already. You'll have all the instructions. So I'm going to do kubectl apply -f deployment.yaml. And you can see all straight away, there's another pod on the bottom left. I don't know if you noticed that, just popped in. So if I can do kubectl get deployment, you can see that we created this new pod called pod info, and it's up and running. And and also we can do kubectl apply kubectl get service. We got another service called pod info. So this is the service and a deployment. Now, I need to be able to access this pod, right? So something's running inside, but we haven't exposed it. And once we talk about Ingress, we'll just run these two Ingresses in a second. Once we deploy, I'm gonna bring in Jen. We'll get Jen to answer some questions as well. So we'll just deploy. We'll get to the point of Ingress, and then we'll answer some more questions. I think there's some more questions. So I need to be able to run this and expose it. So if I run that. Now this is spun up. All we're doing is just exposing the service locally, and we've just opened up the website, but with that command. So it's just running locally, and everything's good. Now the pod is running. We can access it, but it's just running internal to the cluster. I know I've exposed it locally, but what we really want is to be able to access it from outside the cluster. So we want to have the Ingress controller that can take that request and apply. So how do we create the Ingress controller? Now I'm going to deploy. I'll show you how you create the Ingress controller. So if I open another 5, just give me a second. Okay. So in order to create an Ingress controller, you need to get a package from somewhere, a deployment or whatever it might be. An Ingress controller is just a pod. If I do kubectl get pods, you can see I just have this pod running. We're not showing any of the system pods. But when I deploy the Ingress controller, we'll see another pod that will spin up. And that Ingress controller pod is just the load balancer logic inside the controller, that pod that's running, that's listening into the requests that get created. So that Ingress YAML that we're going to create. And the way we can install Ingress controller is by running, by using Helm chart. And Helm chart allows us to create the packages and deploy them easily. So what we can do is in a Helm chart, I'm going to stick that in. So this is just connecting to a registry where the Helm chart lives. And then what we're going to do is deploy an Ingress controller. An Ingress controller is just a pod that runs, right? We're not really doing anything, we're just running pod. It doesn't have to be Ingress. It could be any controller that you like. It could be Ambassador. It could be from anywhere else, any other ones. But we are using Ingress controller right now. Now this thing is going to spin up, is going to run, and it'll deploy a bunch of things. And Helm allows, I don't have to like open multiple files and deploy them. Helm will do that for me automatically. It will create the deployments. It will create the services. It will create everything I need. It will create everything that's required. Now you can see a new pod has popped up with this logo, NGINX logo. Now if I do this thing, kubectl get pods, and you see there's a main NGINX ingress. Now this is the controller part, the special logic that lives in the cluster that basically reads the rules that we pass into using the Ingress YAML, and I'll show you an Ingress YAML in a second. So now I have the controller sitting in the cluster that can receive the traffic and do something with it. But what does it need? What do we need to do? Well, what we need to do is to be able to send the request for all the way from the Ingress top that goes out to the service that goes to the pod. So that's where we bring this Ingress component. So this is the Ingress manifest, the YAML Ingress file. And what this says is it has HTTP rules. This says if somebody hits this request, for example.com, send them to a service called pod info. And that in turn gets sent over to the pod itself via the service. So that's an Ingress. So we got Ingress controller, which is the pod that's running with which basically takes these requests and passes along and implements them. And this is the Ingress resource. And how do you create this in Kubernetes? What you do is you do kubectl apply -f ingress.yaml. And this will create me a kind called Ingress, kubectl get Ingress. Now we've got this we've got this Ingress running. And then I can basically, with this Ingress, if you're in a cloud provider, you might have an address here, and you can take the address and hit that, and it will basically get there. Now, in order to be able to receive the traffic, I can expose this locally, and we're going to try and access this. So this is exposing it locally via an Ingress, so I can basically go into the Ingress, and we're just gonna open a new tab. and basically we can curl. So we've got this IP address, that we can hit, and every time we send a request to that, it will basically go there. So if I do curl, I can't really open it in the browser because it's running, because it's going via domain name, and host example. Then we have this IP address that we can hit, and this response is coming back from the browser that we saw. Now, I don't know. Maybe I think we should stop here for a minute and answer any questions. Jen, is there anything we want to clarify about Ingress or any questions there?
Yeah, we did have an ask to demonstrate this using the NGINX Plus version of NGINX Ingress Controller, or explain the differences. And so I think this is probably a good point to say the version that we're using here is the one that's maintained by F5 NGINX. It's the open source version. We do offer a commercial version based on NGINX Plus. It's very similar in terms of configuration, what we're watching Salman do right now. So there wouldn't be massive differences in deploying it for this particular demo. What you're looking at really is more about the features that you get with it, as opposed to the way that you use it. Both the open source and the commercial versions can be used with NGINX Ingress resources, which are an alternative to Kubernetes custom resources. The one that people here may be familiar with is NGINX open source based Ingress controller that's maintained by the Kubernetes community. So that one is different in terms of configuring than the one that's maintained by F5 NGINX. And so that's just something to be aware of. We are in the process of publishing an ebook. It'll be done at the end of March, that's this month, that'll go over what the configuration differences are and how to actually implement NGINX Ingress Controller, which you can still get from the docs, but it'll be all nicely bundled in one place. So I hope that answers that question. Let's take a look and see. We have all kinds of notes from Chris. He's busy mining the chat for good things to talk about. Let's see. If you deploy multiple images with different ports in the deployment.yaml, do you then just list out all of these ports in the load balancer service? So I'll let you answer that, Salman.
With different, if you deploy multiple images with different ports and that. Okay, I'll answer that in 2 minutes. Let me just get to the demo, and then we'll definitely answer that question in 2 minutes.
Okay.
Casper asked that question. Casper, we'll get to that question in 2 minutes.
Let's go ahead and move back to the demo then.
Cool. So what we got is an Ingress that's running, and that we know you can pick different kinds of ingresses, as Jen was talking about, and we got the open source version that's running. But what we want to do is be able to collect the metrics, and for this case, we need to use Prometheus, and I can install Prometheus again using Helm charts. And I've just done while Jen was talking about it, I just ran a command which basically installs Prometheus using Helm chart. Again, it's kind of similar to how we installed Ingress, which is Helm install Prometheus community. So basically, that's how we installed it. And we can see pods. We can see there's tons of Prometheus different pods that are running inside the cluster that help it to pull things and from the cluster itself. And you can see now we got a few more pods which are running inside. Well, that's okay. We haven't really done too much yet, but what we're going to do now is we want to be able to see Prometheus dashboard, so we can start querying what's out there, right? So I'm just going to again expose it locally, so I can access Prometheus. I'm sure if you've come across Prometheus before, I'm going to bring it here. You've seen this dashboard, and the metric that we're after is this bit, the active connections for NGINX. And currently there's one, because I had just one open. I know you can see, I know it's probably quite dim here, but there's basically just one open connection. This is an open connection. Now, what we want to do is one connection is fine. Our Ingress is sitting there happily, and it can deal with that connection because, it was just me, this request here, right? So I sent this request. Well, that's absolutely fine. No problem whatsoever. But what I want to do is I want to overload the Ingress controller. I want to send too many requests. And what we can do is use this project called Locust. It's an open source project which allows us to load test things. And it's kind of easy to set up. What you do is you create a deployment for Locust. Again, you'll have instructions for doing all of this. The main purpose of this is for us to, like how I accessed example.com using the curl request, we'll get Locust to send those requests. So when I run this deployment file, it will deploy Locust in the cluster. So it will run its own pod inside the cluster, and it's got its own service that it needs to do. But the most important part here is this config map. Config map is the information that stays in the cluster as a key and value, but that uses this Locust file, which basically sends requests to this address that we're doing. So let's go ahead and deploy on the cluster. That's what we want to do. We want to deploy this thing. So let me just open a new tab. And we'll go in here. Let's deploy Locust, right? So I'm going to do kubectl by -f. That's how it is. That's spelling. Everything is created. Now there's a service that I can. So if I do kubectl get pods, there's quite a few. There's a few pods that are coming in. You can see container creating. It's going to come up. It'll take a few seconds. Once it comes up, what we'll be able to do is we'll be able to scale. We'll be able to submit a lot of requests to that cluster, to our website. Now that's up and running. Let's expose Locust. Let's see what we can do. And again, this is going to open another browser, which is in my other screen, but you can see what this is. So this is a really useful tool. I can have a number of users. Let's say we can have 2,000 users. We're going to have 2,000 users. And I can have the spawn rate, like users started per second. Let's start 10 per second. So we gradually ramp up. And where we want to get to is basically the NGINX Ingress pod. That's where we want to hit the header. That's what the header we want to hit. Now, if I go into the chart, if everything works correctly, you can start seeing that this green line here, that's the total requests going in. So they're going up. And the response time is okay, but eventually we only have one pod currently, right? We only have one Ingress pod because the request is heading, it's a HTTP request, so it has to go to the Ingress pod. And what should happen is the number of users should go up to 2,000, and over time the response time might start to increase because the pod can't handle it. And we started to hammer the Ingress controller now. But what we really want to do is to be able to scale this, right? So we want to be able to scale it. And the way we scale this is by using CKAD, right? That's what we said. We're going to bring CKAD to work with grab the metrics from Prometheus, the one that we're talking about, and submit it to the cluster. So before we can do anything, we should install CKAD on our cluster. Again, we're installing everything ourselves, just making sure. We're using Helm because it kind of helps us to install things quite quickly, and you will see kubectl get pods. We're coming to the end of this soon. You can see CKAD operators are coming up. We got 2 containers that are up and running, and and let's start to see this. You can see response times have gone considerably up now. Our container is not happy. We need to somehow scale this. And now once the CKAD stuff is up and running, usually you don't install it every time you're doing this. You install it once in the cluster and it's there. Because I'm doing it from a fresh cluster, that's why it's happening. So a CKAD operator is going to come in a minute. And then what we can do, this is where all the magic happens. We can use, when we install CKAD, it creates another resource in the cluster. I know we talked about deployment. I know we talked about Ingress. I know we talked about services. But you can customize types of resources. In our case, that's called a custom resource definition. In our case, it's called a scaled object. This part of CKAD. And this is where all the magic happens. All this says is we're going to target a deployment. We'll give it a name. That's main NGINX Ingress. That's the name of our deployment. And the trigger, and we define the replica counts, 21 or whatever it is. And basically what we have is this bit here at the bottom, which is the most important bit. That what we want to do is get the metric that we want to get, and NGINX Ingress connections live from our Ingress pod over a period of 1 minute, average it, and give us a sum. So basically number of active connections. And if that's over 100, scale. That's all we want. So that's what we're going to do. Now, here's the, so far, that's what we got. So I'm going to bring it all, everything. Let's just quickly deploy this. We'll just create the scaled object, and we should, hopefully, if everything works, we'll basically, it'll spool up, and we'll have more than one ingress automatically, as if by magic. So if I go here, 1 minute, we're coming to the end of this. Thanks for sticking around. Last part. Let's see. Apply -f. We got the scaled objects. So it's create the scale. And if you keep an eye on the left side, hopefully it should spin up more instances of pods to be able to handle them. Ingress. So let's see. kubectl, get, oh, there you go. Yeah, there we are. We've got more pods automatically spinning up because we've got all that request coming in. And we can, the way it works is basically it takes the metrics and passes it on to the horizontal pod autoscaler. And the horizontal pod autoscaler basically spins up. Hey, we got more pods. We got more ingresses spooling up. And hopefully what we should see is the response time start going down because multiple instances of pods are running. And the total requests are also going down because we've got instances running that can bring them, bring the information down. Oh, we got many more instances up and running. You can do kubectl get pods. And basically, we've just scaled our application based on, you can see all these ingress pods that are running. Basically, all we've done is scaled our application based on the requests that are coming in. By the way, if you haven't answered your question, please make sure you leave them in the chat. We'll definitely put them out on the YouTube. I'm just conscious of a bit of time. If you're watching it afterwards as well, just stick your comments in the YouTube section and we'll answer it. So that's what I wanted to show you. Let me just quickly hop back to the slides because I know we're running out of time. So what you just saw is, let me just, we did all of this, Minikube cluster, we installed all those tools that we needed, we generated load, we auto-scaled it. What you saw was a single NGINX pod running. We queried some metrics, one metric that we were using, we calculated, which was our threshold using CKAD. We pulled CKAD in, and CKAD fed the information to horizontal pod autoscaler that increased the number of deployments that we needed. So we went from one to many. So we basically scaled for when we had too much traffic. And eventually, if we keep it running, we'll see the responses will go down. So let me give you a quick summary. So we talked about why Kubernetes is important. You know, it gives us all the problems that we had with virtual machine deployments, and it can scale up and it can deploy in multiple instances. We talked about deployments, which is just recipes for how many pods you want to run and how you want to scale them. We talked about services, the services that run as internal load balancer, which is an abstraction on top of a pod. We talked about Ingress, two parts of Ingress, Ingress controller and Ingress manifest. Ingress controller is the bit that sits in the cluster, like a web server, NGINX, and Ingress is the rule that we write in that basically takes the request and passes on to the service. And then we saw a demo in which we did an auto-scaling. Now, if you want more information on this stuff, you can head over to Learnk8s.io. Definitely head over to nginx.com/mm. There's a lab for this that you can do exactly what I just did. There's a pretty cool demo by Jen online as well that you can check that out. And there's tons of blogs on there. You can check our website, Learnk8s.io. It's got more blogs and we do some training. You can check that out. You can follow me on Twitter as Salman Iqbal, and you can also subscribe to my YouTube channel if you like, and I cover stuff like this. That's what I wanted to cover. Jen, let me bring you back in.
That was great. Thank you. I love that demo. I love being able to flip back and forth between Prometheus and Locust and see those little pods getting added and how much happier it is. So like you said, we have this available as a little bit more self-contained demo environment where everything is there already for you. You don't have to be installing it. But let's go ahead and get over to some questions. So, Marco, why don't we bring up that first one we had earlier on, where did it go?
Yeah.
Multiple
I think I've got
images.
the chat here.
If you deploy multiple images with different ports in that deployment YAML, do you then just list out all those ports in the load balancer service?
Oh, so basically you wanted to be able to send the request from the service down to the multiple images. Yeah, so basically you have to define a different port that you want to send it to. Exactly as you're saying, you're going to have to list it out in that service and say, send this request to this port, because you might want to send, / checkout to one service and / to a different pod. So you can list that on there.
Okay, next question. How are you mapping the ingress with the ingress controller? I think we saw a little bit of that in the demo in your manifest, right?
Yeah. Yeah, so the mapping between ingress and the ingress controller, if I can just open this in a second. Well, as in the mapping between the ingress and ingress controller. So I'm not sure I get that question.
Yeah, looking at ingress class.
Oh, right. Okay. Yeah, the ingress class name here. Sorry, this bit here, the ingress class name, and NGINX. That's how we mapping it.
Easy peasy. Let's see here. Explain what type of service load balancer is.
Yeah, it's a service load balancer. Is if you use that in a cloud provider, it will actually create you an actual load balancer. That's what the service type is. So you can use it externally to receive traffic. And you might say, well, why can't I just use that? Why do I have to use ingress? Well, the load balancers are pretty expensive, and you can't. If you have multiple services, you might end up with lot of load balancers that could cost you a lot of money. And it's specific to a cloud provider. Right? Yeah, and it's specific to a cloud provider. If you're running on-prem, you might have to look up something else like MetalLB.
Yeah, what we often see is people using like a single load balancer or a couple load balancers outside the cluster, funneling traffic to an ingress controller. That's pretty common.
Okay, cool.
Let's see here. We have another one. Do Prometheus and CKAD need to be in the same namespace as the pods in order to see those pods? They don't.
No, they don't have to. Yeah, no, they don't have to be in the same namespace. We just have to make sure. Oh, right, what you didn't see at all in the setup that I have is there's no RBAC, right? It's because it's local. Everything's open. Every pod can talk to every pod. So they don't have to be in the same namespace. We just have to make sure wherever they are, they have permissions to be able to talk it. You should have a cluster with the right RBAC, right network policies, so the right pods can talk to each other.
Okay. Is there something, such thing as a default ingress? And then somewhat related question, which are the more important advantages of using NGINX instead of a default ingress? There is no such thing as a default ingress. So it's more about what you need in terms of use cases as to which ingress controller you choose. So Salman, how do you choose?
Well, you try it out first. You look at what your requirements are and see what you need. And you can open the documentation and check out like what kind of info, what kind of, maybe you want sticky sessions, right? I don't know. It's just something I picked out the top of my head. Most ingresses might provide it. Some ingresses might not provide it. And then, you can see if it's got everything that you need, then you can pick one. Well, definitely what I'd say the best thing to do is try it out. Pick one, run your local machine. Have a look at our research, learnk8s.io/research. That's got a comparison of all the ingresses. If you have any questions about NGINX, Jen is the person to talk to. I'm sure she's going to say NGINX is the best. I've used NGINX a lot, and
it's pretty good.
Yeah, I haven't had any issues with it, so it's all
good. One of the big things that we advocate for is choosing one that's going to be agnostic in terms of environment. So you can take it from environment to environment. You're not ending up with an ingress controller that can only be used in one environment. That can, just cause more work. One of the items in the description for this video is a blog. It's kind of the companion blog to go along with this session of the same title. And so in that blog, we have our guide to how to choose an ingress controller. And I mean, long story short, like just about everything, it's choose the one that works best for you. But it's going to kind of walk you through things that you might not really think about, as you're choosing. Let's see. Perfect. And then we've shared the Learnk8s comparison. I think that's going to get put in the chat as well. So that's a really nice side-by-side feature comparison. And okay, what is the difference between CKAD and HPA? HPA is a feature of CKAD, right?
Yeah, so HPA, kubectl get HPA. This is like another resource within inside Kubernetes. So this is something that you can define to scale up your your deployments, right? You can say, oh, if the CPU goes above a certain value, just give me another pod, right? So you can define this using the horizontal pod autoscaler. But the problem is you need to get that metric from somewhere and provide it to the horizontal pod autoscaler to be able to scale it. How do you do that? And this is where CKAD comes in handy, because CKAD can talk to Prometheus, grab that metric, and actually feed it to the horizontal pod autoscaler. So you can run this command kubectl get HPA. It will show you the horizontal pod autoscaler in your place. But basically, think of CKAD as the bridge between the metrics and the horizontal pod autoscaler. It's taking the information, passing it to the horizontal pod autoscaler, and that's actually spinning up or spinning down number of replicas that you want to run.
Yeah, like if you scroll to the side a little bit after max pods, you can see how many it's actually deployed right now. Oh, no, it might be below. Where is it?
Yeah, I think it's just gone.
There it is, replicas. So it's showing you how many are out there. So it's kind of a cool command also. Okay, we have another question. Can you explain scaling up pods versus scaling out pods?
Yeah, so scaling up, I guess scaling up clusters, you can get a bigger machine to scale up. Scale up pods have multiple instances of the pods running, like the replicas as you saw. I think is that have I read that question correct, Jen?
I don't know. Okay, I think we're on it.
Okay.
Next one, when you are doing the auto scaling, how do you ensure between your Ingress controller replicas and your app replicas that you're not overloading your hosts? How does failure to scale look?
Hey, that's a really good question. That's a really good question. So a lot of preparation, and I'll answer that in a second. So I know we saw in here scaled object. We got maximum replica counts right here. We got counts. We says minimum 1, maximum 20. But you need to get the number somehow. How do you get it? Okay, you can guess and you can try it out, but there might be a better way. So what you can do is, I'm just going to show you real quick. You can actually go to our instance calculator, Learnk8s. I'm just going to go in here, and you can decide. You can basically have a look at how many pods you can run. So you can pick an instance, and main cloud providers, GCP, AWS, Azure, and you can figure out what instances of your applications are running, how much memory requirements they have, how many CPU requirements they have, how much CPU requirements it has, and you can basically figure out how many instances you can run in each of the nodes and how many clusters, how many nodes you can have. I mean, the easiest answer would be just make sure you have a cluster autoscaler. So if anything, if things start to get choked, and you can basically scale out the cluster and get everything running. But you can do a bit of prep work beforehand by trying to figure out and gather some metrics and trying to figure out how much you can run inside the cluster, and make sure the Ingress, you got enough Ingresses running, make sure you got enough place for your clusters to run to. The smallest, the easiest problem is to have a cluster autoscaler, but solution is, but that costs a lot of money, right?
Yeah, and depending on your Ingress controller, different metrics might be exposable. So the one that we've demoed today, the open source version, comes with 8 metrics. The NGINX Plus version comes with over 80. And so that can also help you make sure you don't run out of resources. Let's see. What have we hit? Can you list differences between service types behind Ingress? And so it lists load balancer, cluster IP, and headless.
Yeah, so basically headless service is just, well, we go into a bit of detail now here, but that's cool. Headless is just basically the endpoint. So if you have a headless service and you query a headless service, if you dig for it, it'll just give you the IP address of the pod and the node port. If you've got multiple instances of the pod running, the application's got to do something in picking one pod. So that's a headless service. The cluster IP service is built up on top of headless service, but what it does, it just gives it this fake IP address that pods can call. So what that means is a pod can refer to a different pod using the service name. So that's basically just a little bit more. And load balancer, then NodePort comes in above cluster IP, and NodePort basically just exposes a port. So whatever you have in cluster IP and headless, you get a NodePort. It exposes a port on the node that you can access from outside. And load balancer actually gives you an actual load balancer on top. So if you spin up in a cloud provider, you get a load balancer.
All right. And then finally, let's talk about auto scaling down. Why should you care about that, and how do you do it?
Perfect. And I think there's auto scaling, vertical pod auto scaling as well. I think I just remembered, Jen. Maybe they're talking about optimizing the size of the pod by increasing, making it like making optimal CPU and memory resource work. I think that's what it is. It could be that. But now let's answer the other question about scaling down. Now that's very important. Imagine you have a cluster that you scaled up because maybe you manually logged in and you scaled up, and you instead of like 2 replicas, you're running 15 replicas, but you don't have enough. After like 2 days, you don't have enough traffic. What you really want to do is make sure that you have some mechanism, HPA perhaps, or like CKAD, that's listening into the metrics and scaling your nodes down, scaling your workloads down, because you don't want to waste all that resource. Because if you have a cluster autoscaler, you're perhaps paying for more nodes than you really need. And if you scale down, you can start saving on those resources, and Kubernetes can package everything correctly.
Yeah, great way to make sure that you don't waste money. So let's go ahead and start closing out here. I know there are lots more questions as well, but we're over the hour. So Marco, let's switch over to the other image. Thank you. So we have 3 more units coming after this week's Exposing APIs with Kubernetes, which is going to be all about API gateway use cases, microservices security pattern, and advanced Kubernetes deployment strategies. Each of those units, as well as this one, comes with 3 parts: a high-level live stream, which congratulations, if you've made it to this point, you've completed it. Technical, reading, not ready, and videos. So if you look in the description of this video, you'll find that. It's going to give you a deeper dive on these topics. So that might answer some of the questions you have lingering. And then the third portion is a hands-on lab. In order to get access to the hands-on lab, you do need to register at nginx.com/mm. And then the other way that you can engage with us is on Slack. Right now, we're linking that with the Microservices March registration. And so if you register for the lab, you automatically get an invite to join Slack. And so you can come ask questions. It sounds like there's lots of people with knowledge in the comments who can also be part of this community and talking about it. And that's it. So Salman, thank you so much. I think we're going to see you for the final unit, right? You'll be back for advanced deployment strategies.
No, I'll give that honor to Andrea. Andrea's going to do that. He's going to do that. He's going to do one next week and the week after.
Excellent. Well, I think you'll be here to help us answer questions in following weeks. So this has been great. Thank you, everyone, for joining. Have a good evening or morning, wherever you might be.
Thank you all.